In general, an object experiences a loss of weight in water due to the upthrust, and it is equal to the weight of water displaced by it. This is better answered using the law of buoyancy, also known as Archimedes Principle, named after the Greek scientist who discovered it. Archimedes' principle states that when an object is immersed in a liquid, the apparent loss of weight of an object is equal to the upthrust, and this is also equal to the weight of the liquid displaced. We see the uses of this principle in our daily lives. Have you ever caught a fish with a fishing rod? When pulling the string, you would have felt the weight of the fish in the water is lighter than when the fish has surfaced. Say the weight of the fish in the water is 2 kilos, its approximate weight outside would be 3 kilos. Well, the water level too has come down. This difference in the volume of the water level will equal the loss in weight of the fish when in water. That is, the weight of the fish when outside minus its weight when immersed in water equals the loss in weight of the fish. So the loss in weight of the fish will equal the weight of the decreased water. This is because the upthrust or buoyant force is equal to the weight of the decreased amount of water. Let's do an activity. Arrange apparatus as shown. Now take an object weighing 5 kg. Immerse the object. Here a 5 kg object immersed in water is shown being acted upon by a buoyant, upward force of 2 kilograms, which is equal to the weight of the water displaced by the immersed object. The buoyant force reduces the object's apparent weight by 2 kilograms, that is, from 5 kilograms to 3 kilograms. Thus, Archimedes' principle is verified. Certain technologies today work based on Archimedes' principle. To name a few, the designing of ships and submarines, hydrometer is used to find the specific gravity of the liquid, and lactometers used to determine the purity of milk. Things too. Remember, the upward force exerted by a fluid is called upthrust or buoyant force. Upthrust or buoyant force equals volume V into density ρ into small g, acceleration due to gravity. Archimedes' principle states that when a body is partially or fully immersed in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Archimedes' principle is also known as the law of buoyancy. Take a jar filled with water up to the nozzle. Place an empty ball below the nozzle. Now, take any solid object you like and measure its weight using a spring balance. Note this down. The object weighs 4 kg. Keep the object attached to the spring balance and submerge it in the water. Just make sure the spring balance is not submerged. Now, note down the weight shown by the spring balance. You will notice that it is less. Yes, the weight of the object showing 3 kg. You will observe that some water will be displaced into the ball. Collect this water and weigh it. The weight of the displaced water showing 1 kg. You will find that the weight of the water will be exactly equal to the loss of weight of the object. The mass of the liquid displaced is mass is equal to density into volume is equal to ρ into V. This is because density, ρ, is defined as ρ is equal to mass divided by volume is equal to m upon V. Thus, the weight of that displaced liquid is weight is equal to mass into acceleration due to gravity is equal to ρ into V into g. Thus, from the Archimedes principle, we can write the apparent loss of weight is equal to weight of water displaced is equal to ρ into V into g. Thus, the thrust force is thrust is equal to ρ into V into g, where ρ is the density of liquid, V is the volume of liquid displaced. The thrust force is also called the buoyant force because it is responsible for objects to float. Thus, this equation is also called the law of buoyancy.